Hi, I'm Pam Lahoud, Program Manager with the Azure Data team, and today I'd like to talk to you about running SQL Server in an Azure Virtual Machine. So SQL is everywhere. You can run the same SQL Server engine that you know and love on any platform, be it cloud, on-prem, Windows, or Linux, and it's the same SQL engine no matter where you run it. So, of course, we have SQL Server 2019, which is your on-prem version of SQL Server that you know and love. You can run that on Windows or you can run it on Linux. Again, it's the same engine. It's fully compatible. So you can take a database that you have on Windows and you can take a backup and restore it on Linux. It's the same. We have SQL Server in containers. So similar to the SQL Server engine running on Linux, you can run it in containers. You can even run it using Kubernetes, which gives you more options for deployment at scale and high availability. And then, of course, moving into the cloud, you've got SQL Server Virtual Machines, SQL Server Managed Instance, Azure SQL Databases, and SQL on the Edge. So SQL, the IoT version of SQL Server, in case you want to run SQL Server on, say, a Raspberry Pi. And so all of these different flavors of SQL Server have the same code base. They are essentially the same database engine. So no matter where you're running your application, you should have a similar experience. Some of the management may be different on these different platforms, but the engine itself is the same. So again, as we mentioned in the beginning, we're going to focus on SQL Server running in Azure Virtual Machines today. So when you're talking about cloud versions of SQL Server, what are you running when you get into Azure? You essentially have three options: SQL Server Virtual Machines, Managed Instances, and Azure SQL Database. So SQL Server Virtual Machine is what we would call an IaaS solution, infrastructure as a service. So in this case, we manage the hardware for you and the hypervisor, but you manage the virtual machine itself. So from the operating system up is up to you to manage. So this is going to be actually very similar to managing an instance of SQL Server on-prem, especially if you're already using virtualization. But you are responsible for things like patching SQL Server for high availability, disaster recovery, backups. All of that falls on you, since this is infrastructure as a service, not platform as a service. Managed instances, on the other hand, that is a PaaS solution, or platform as a service. So with managed instance, you still get access to a full instance. You can have multiple databases in the instance, but we manage those instances for you. So we manage things like high availability and disaster recovery, backups, all of that sort of management that you would normally do in an on-prem system. And then, of course, Azure SQL Database, which is a full PaaS solution, platform as a service solution. So here it's a single database. Optionally, you can have an elastic pool that has multiple databases, or hyperscale and serverless. But there we manage everything for you. High availability, disaster recovery, all of that is managed for you. You simply need to manage your application. So when it comes to doing what we call lift and shift, where you just take your application and plop it up into the cloud without making changes, the two options for lift and shift would be SQL Virtual Machines and Managed Instances. These are going to give you the closest experience to what you're already running when you're running SQL Server on-prem. So the difference here is really how much do you need to manage? So IaaS versus PaaS. So with Managed Instance, everything is built in. Business continuity, high availability, backups, long-term retention, geo-replication, anything you need to manage as far as infrastructure goes, we take care of that for you. Of course, you do still need to monitor your application and do things like query tuning and index maintenance, but you would have to do those even in Azure SQL Database. So everything, the kind of hard and boring stuff, the HADR stuff, we manage all that for you with MI. The trick with MI is there may be some restrictions or some things that you need that aren't available in MI. One of those things is maybe OS level access. So for example, you have some kind of a third-party software that runs on the SQL Server, or maybe your application is only certified to run with a specific version of SQL Server. You have to have SQL Server 2016, for example. In that case, you might need a little bit of extra control over what you're running. So control versus manageability is really what drives the choice when you're doing lift and shift between MI and Azure VM. So with Azure SQL VM, you can still get things like high availability and automated backups and things like that, but it requires a little bit of extra work on your part to configure that. You have to choose your automation. You would need to you would need to manage everything from the operating system up, and we do have ways for you to do that in Azure, ways for you to automate that in Azure, but it's up to you to set that up. And so you're going to have more management responsibilities if you're running an Azure SQL VM. So you do have the benefit of some of the Azure services that you would get with anything in Azure, but you have more control. You have control from the operating system level up. So one of the other cool benefits you get running SQL Server in an Azure VM is you're able to leverage your on-prem investments in SQL Server in Azure. If you have software assurance, there are certain benefits that you can get running SQL Server in an Azure VM. So first, if you're only in Azure, your first HA and DR, HA high availability and disaster recovery cores on Azure VMs are free. So what we mean by that is if you're running an availability group in Azure, you can have one synchronous replica and one asynchronous replica for free. So you license the first, the primary replica, and then you get a free HA and DR instance in Azure. Also, if you've already got software assurance on-prem, you can use your licenses that were purchased for on-prem SQL Server in Azure. So that's something called Azure Hybrid Benefit. So if you've already purchased the licenses, you can apply those licenses to any VMs that you create in Azure. So you're able to leverage that investment that you've already made. If you're going for a hybrid deployment, where you have on-prem instances of SQL, and then you also want to have, say, disaster recovery in Azure, you can use the Azure DR benefit. So what that allows you to do is have your first DR replica in Azure for free. So you can have your on-prem replica, so you're entitled to one HA replica and one DR replica on-prem for free. You can also have an additional DR replica in Azure for free. So that allows you to satisfy, say, having multiple data centers. You can have your on-prem data center plus Azure as a secondary data center that gives you some extra protection for DR, and all of that is included in your software assurance. And then the last bit is if you're running older versions of SQL Server and you need extended security updates, if you move those older versions of SQL Server into Azure VMs, you can get ESU for free. So all of that patching can be automated using the Azure resource provider tools, and you get those patches for free when running in Azure. Okay, so as I said, running with an Azure VM means that you still are responsible for some of the maintenance that you wouldn't be responsible for if you were in a true PaaS platform as a service solution. So what about the cost of doing that management? You're not really, maybe you think you're not really taking advantage of everything that's available in the cloud if you're going with SQL VM. We offer in SQL Server a resource provider that allows you to leverage some of those great Azure cloud services for your SQL servers that are running in Azure VM. So the resource provider gives you features like auto patching, automated backups, and management of your SQL Server VMs simply by registering them with this resource provider. You can discover all of your SQL Server VMs. There's a SQL Server VM blade in the Azure portal, so you'll have a dashboard. You can see all of your SQL Server VMs running, and you can manage licenses for those SQL servers. So we talked about that Azure Hybrid benefit. Let's say someone deployed a SQL Server in Azure and they weren't aware of the Azure Hybrid benefit, and you want to change the licensing from the pay-as-you-go, which would be the normal licensing in Azure VM, to the Azure Hybrid benefit. How do you do that? If you have the resource provider enabled with or registered, you have this VM registered with the resource provider, then you can make that licensing change on the fly. And then this also allows you to manage licensing in a much more simple way. So when you want to leverage that Azure hybrid benefit, if you don't have the resource provider, then there's paperwork that's involved with leveraging that benefit. As long as you register with the resource provider, we take care of that for you. So we automatically indicate the Azure hybrid benefit usage, provided that you're registered with the RP and you've indicated that VM as Azure hybrid benefit. So if we look at the configuration of a SQL VM in the Azure portal, you can see here in the example on the slide, the different license types that are available for your Azure VM. So the pay-as-you-go, where you would pay, per minute, or the Azure hybrid benefit, where you leverage your on-prem licenses of SQL Server for your Azure VMs, or the disaster recovery benefit, where you're just running a DR replica in Azure. So these are your options for licensing, and the resource provider allows you to easily switch between these license models for your VMs. As I mentioned, we have the dashboard as well. So we have a blade for SQL Virtual Machines. Any virtual machine which is registered with the resource provider will show up in this list. So this gives you a way to, at a glance, see all of your Azure VMs that are running SQL Server, and also be able to see the version of SQL Server that they're running, as well as the license type. So you can manage all of your SQL servers quickly and easily through the portal itself. The resource provider is registered automatically if you use one of the marketplace images to build your VM. So if you've already built SQL Server VMs using a marketplace image, you're all set. You already have the resource provider. But if you've self-installed SQL Server, so you've just built out a VM, and then you installed SQL Server yourself on that VM rather than using a marketplace image, then you may not be registered with the resource provider. So in that case, if you want to be able to leverage these benefits, then you would need to manually register your virtual machine with the resource provider. So today, if you're running SQL Server 2016 or higher, and you have the telemetry service running, which is running by default, so if you haven't disabled the telemetry service, then we will be automatically detecting your SQL Server VMs, and we'll be registering them with the resource provider for you. So if you're running 2016 or higher and you have that telemetry service running, then we'll take care of this for you, and you should start seeing your SQL Server VMs showing up in this dashboard view. But if you're running SQL Server 2014 or lower and you haven't used a marketplace image, then you're going to need to manually register your VMs. So you can do that by using a simple PowerShell script. The first thing you need to do is register the subscription itself with the resource provider. This is one time only. No matter how many VMs you have, you only need to register the subscription once. So this first command registers the subscription with the SQL resource provider. And then once that's complete, then you can register your VM. So if you'd like to just do a single VM, then this command will register a single VM with the resource provider. But if you have several SQL servers that are running within your subscription, then you might want to register all of them at the same time. So for that, there's also a bulk script that you can use. So this PowerShell script will enable the SQL Server resource provider for all VMs within the subscription that are running SQL Server. So you list out your subscriptions here in the command, and then the script will automatically look at those VMs, detect which ones are running SQL Server, and register with the resource provider. Now, there are two modes for the resource provider. The full version, which gives you everything that we talked about, auto patching, always on, auto backup, high availability configuration, things like that. But that full version requires a restart. So if you want to register all of your SQL Server VMs with the resource provider, but you can't do a restart, or you want to do a restart later, then you can register them with the lightweight version. The lightweight version gives you the licensing, the ability to detect and manage all of your VMs, and it gives you the ability to change the licensing, but it doesn't give you some of the other features like auto backups and auto patching. So for the lightweight version, that just gives you discoverability and licensing. And then if later you can do a restart, then you can upgrade that from the lightweight version to the full version later. So the call to action here is to make sure that all of your SQL Server VMs in Azure are registered with the resource provider so that you can take advantage of all of the features that are available to you in Azure. So the next thing we're going to talk about is performance for SQL Server in your Azure VMs. And this is really the bulk of what I wanted to talk about today. So when you go to create a VM in Azure, there are a lot of options for you for the different types of VMs, the different sizes of VMs, and it can be a little daunting. So what I have on the slide here is just kind of a summary of some of the different classes of VMs that are available. You've got basic VMs, entry-level VMs, burstable VMs. These are VMs that allow you to burst above what would normally be the storage limits, so the IOPS and throughput limits. So if you have periods of time where you know you're going to go above or have a high number of IOPS or a high amount of IO throughput, then burstable is an option for you. General purpose and confidential computing, compute intensive, memory optimized. So these would be VMs that have a large amount of memory, GPU accelerated, high performance computing, and storage optimized. So which one do you choose for SQL Server? Well, we do see a fair number of the general purpose VMs being used. So these would be probably for your lower end SQL servers, ones that don't have heavy demand for performance. But for most of our performance conscious customers, memory optimized and storage optimized are the most commonly used for SQL Server workloads. These VMs have, they do have, you can get them with a large number of cores, but the ratio of memory and storage to cores is more in the sweet spot for SQL Server. Because what we find for SQL Server is that you have a high demand for memory, you have a high demand for I/O, obviously because we're storing data and retrieving data, but the CPU demands are generally not as high. So you'll find that the optimal ratios between CPU and storage is usually in these classes of VMs. So M series is very common, L series is very common. And then the burstable is also one that's common. So when you're performance conscientious, you probably want to start by looking at these VM sizes. Any one of these can work for SQL Server. It really has to do with what your needs are. But what you're going to find here is that you really need to understand what your workload is on-prem before you can migrate it into Azure. Because, when you're on-prem, you're buying a server, you're buying like a SAN, for example, for storage, and those are all high performance. And you're not necessarily thinking about, well, how many IOPS am I going to generate? How much CPU am I going to use? You're just kind of buying the hardware that you think is appropriate. And then you're leveraging your on-prem investments for your different SQL Server workloads. When you get into Azure, you are paying specifically for the resources that you're using. And so you're kind of like renting the hardware. So in that case, you really want to be conscientious about how much IOPS are you using, how much throughput are you using, how much memory are you using, because you're paying for that. So you have to kind of get a handle on what you really need in order to get the best price performance ratio in Azure. Okay, so once you choose your compute option, your VM size, then you'll have to look into storage. Generally for SQL Server, we recommend either Premium or Ultra. Couple of reasons for that. These are going to be the closest to what you're probably leveraging on-prem as far as IOPS and throughput capacity, as well as latency. But also, you will find with SQL Server that caching is incredibly important. Leveraging the cache in the VM allows you to limit the amount of IOPS and throughput that's going to the remote storage, and that can help tremendously with performance. So the Azure Blob cache is only available on the Premium and Ultra. So for those, so for SQL Server workloads, we really recommend that you go with Premium or Ultra. because of the caching and the performance demands. So Azure Blob Cache. So this is that it's read-only caching available on the premium SSDs. And this is what allows you to really get to the level of IOPS and throughput that SQL Server workloads demand. As I said, we generally have a higher demand for storage than other workloads, and we usually don't need as much CPU performance as we do IOPS and memory. So Azure Blob Cache is your key to getting the level of storage performance that you need. Even for write-heavy workloads, you're probably still going to see benefit from that read-only cache. So some of the numbers that you see on the slide here are from some benchmarking that was done using HammerDB with TPCC. And you can actually get quite good throughput, but the key is making sure that you're sizing appropriately, using the right disk, using premium or ultra, and leveraging that read cache. Now, what you can find, as I said, SQL Server, memory intensive, IO intensive, what you can sometimes find is that in order to get the IOPS and throughput that you need, you end up having to choose a larger VM size than you would like. So what I mean by that is you may have to go up to a higher number of CPUs, vCPUs, in order to get the IOPS and throughput you need. The problem with that for SQL Server workloads is that SQL Server is licensed per core. So the more cores you have, the higher your licensing costs are. And when you're talking about sizing a VM, those SQL Server licensing costs tend to be the bulk of what you're spending. So in order to achieve those higher IOPS and throughput, but not have to pay so much for SQL Server licensing, we offer something called constrained cores or constrained vCPU VMs. These are virtual machines where you are paying for the compute and the IOPS and throughput of a higher CPU machine, but we are constraining them to smaller number of cores so that you don't have to pay the same licensing costs. So for example, on the slide here, you can see this standard M8 2MS. What this means is it's the same as the M8MS VM series, which would normally have 8 vCPUs, but it's constrained to 2 vCPUs. So you get the IOPS and throughput that you would get with that 8-core machine, but you only have 2 cores, and therefore only 2 cores need to be licensed for SQL Server. So this is a way that, again, you can achieve a better price-performance ratio when leveraging SQL Server in an Azure VM. And again, a link on the slide that talks a little bit more about the idea behind constrained vCPUs. Not all VM sizes and classes are available with constrained CPUs. So if you want to know which ones are available, this documentation will tell you which sizes are available. But I do find many of the most common VM sizes that customers are leveraging for SQL Server are available in constrained cores, those M series and MV2 series VMs. Okay, so what else? What else do you need to worry about with performance in Azure VM? Well, as I mentioned, the SQL Server that you're running in an Azure VM is the exact same product that you're running on-prem. So really anything that you would do for performance on-prem, you also want to do that in Azure. Things like making sure you have lock pages and memory turned on, especially for high-end machines. Instant file initialization if you're in Windows. Any query performance best practices, tuning best practices, all of that is the same. Your queries are going to run the same whether they're up in Azure or whether they're on-prem. So any kind of tuning that you would do on-prem, you would do the same thing in Azure. And in fact, it becomes more important in Azure, remember, because you're renting that hardware. You're paying for that hardware per minute. So anything you can do to tune your queries is going to minimize your cost and give you better performance in Azure. Same if you're running SQL Server on Linux in an Azure VM. So we have best practices specifically for Linux configurations and certain optimizations, file system optimizations in newer versions of Linux. So RHEL 8 has some XFS file system optimizations that you might want to be leveraging. So most of the guidance is the same. The few things that are different generally have to do with IOPS, because this is where things can be challenging in Azure. And the reason for that is when you're sizing for storage on-prem, you're not usually thinking about how many IOPS you're generating or how much throughput you're generating. You're really just kind of looking at the size. You buy like the the best SAN you can get, the latest and greatest storage configuration you can get, and then you carve out some size from that SAN, and that's what you use for that SQL Server, and you're not really thinking about IOPS and throughput. But when you get to Azure, you are buying storage based on IOPS and throughput. The storage you are buying, the difference between the storage types that are available comes down to how much IOPS and throughput each one of those storage types supports. So you really have to think about sizing storage more than just capacity. It's more than how big does the drive need to be. It's how many IOPS and how much throughput can I get from that drive. So it's kind of a different thought process than many DBAs are used to thinking about when they're sizing their systems. So on-prem testing, and I think I've said this before, but I'm going to say it again because it's so important. On-prem testing of your workload is incredibly important to make sure that you choose the right size and the right type of storage once you get into Azure. So you want to be collecting peak and average IOPS requirements for data log and tempdb, preferably separately because you're going to be separating those out and you may choose different storage for each one. In fact, generally we recommend that your data files go on premium SSD, your log files go on ultra SSD if possible because that's the lowest latency, and then tempdb, because tempdb is ephemeral and it doesn't need to persist reboots, you would put tempdb on the local ephemeral storage. That way, it doesn't go against your remote storage IOPS and throughput limits, and it's a little bit faster. So because you want to separate these things out when you get to Azure, you need to measure them separately so you understand the IOPS and throughput requirements of each one, data, log, and tempdb. So then you need to choose a VM size that can scale to your maximum IOPS. You have limits on the disks themselves, but you also have limits at the VM level. So even if you have multiple, say, P30 drives, I've got 4 P30 drives, I add them all together and I get the IOPS and throughput I need, you also have to look at the limitations at the VM level and make sure that it meets those requirements. So you've got to look at your peak as well as your average. In some cases, you can leverage that burstable. So if your peak is very different than your average and your peak is only for a short period of time, you may be able to leverage one of those burstable VMs. Otherwise, you need to make sure that you size to that peak, or you do some testing and you find out, okay, if I'm throttled and I can't get to my normal peak, how long will I be throttled and how much of a performance hit is that going to cause me? So you would definitely need to do some testing there. So read-only cache, incredibly important. So you want to be using premium SSD so that you can get that read-only cache. It needs to be less than 4 terabytes. The data file needs to be the disk needs to be less than 4 terabytes in order to use the read-only cache. So if you have more than 4 terabytes requirement, then you would want multiple disks that are smaller so you can leverage that read-only cache. And then so you use the multiple disks, as many as you need to get to your IOPS requirement, and then you can stripe across them using like storage spaces. Ultra disk, it is obviously going to be the lowest latency and the best performance, but it tends to be a little bit pricey. So if you really need that low latency requirement, you can try ultra disk for the log first. And then as you're monitoring your performance, if you find that disk becomes a bottleneck, then you can consider ultra disk for your data files as well. Here's the thing though, when you choose storage and you put your database files on that storage, you can't easily change your mind. So you can't easily go from premium SSD to ultra SSD or from a P30 to a P40 to a P50. You have to actually copy all of your data from one drive to another. So you want to make sure that you work out all this sizing during your testing, because once you go into production, it's not so easy. Sure, you can resize the VM itself. You can size up to a different VM, but resizing the storage involves a lot of data copy. So it's not something you can easily do on the fly. So you really want to work out all these requirements while you're in the testing phase, and then you can, and then hopefully once you get to production, you'll have what you need. Now, I know this sounds a little bit daunting, so of course we do have some tools that can help you with this. The Azure Migrate tool can help you right size your VM based on your current on-prem workload. So using the Azure Migrate tool will allow you to capture data on-prem and then feed that data into a tool and receive some recommendations on sizing for your VMs. And this can help you choose the right VM size as well as the right storage size for you. Okay, so call to action here. To optimize your price performance, the way you do that is by understanding your workload, particularly IOPS and throughput and how much that you really need. And we have some performance best practices for SQL VM. That is an article that's available in our online documentation, and that kind of walks you through all of the best practices like turning on read caching, putting tempdb on the local drive, and all of that. The last thing I want to mention here as well is that resource provider that we talked about earlier. If you're using the resource provider for SQL Server 2016 and higher, it will also help you choose the right storage configuration. It can help you make sure that you're following those best practices. So take a look at that article, look at the Azure Migrate tool, and use your existing on-prem workload and whatever performance monitoring you have there to guide you once you're moving up into Azure. Okay. Next topic we want to talk about is high availability and disaster recovery, because remember, when you're in Azure VM, that is an IaaS solution, so you need to be configuring high availability and disaster recovery yourself. We're not going to do it for you like we would with managed instance or Azure SQL Database. So what technologies are available to you in Azure VM? Again, it's basically on-prem SQL Server. So pretty much anything you can do on-prem, you can also do in an Azure VM. You have availability groups. You have failover clustered instances. You have good old tried and true log shipping, which still works, even though it's old. It's simple and easy. And if that works for you, great. You can just do simple backup and recovery. And in older versions of SQL Server, of course, you had database mirroring. So all of these choices are available to you in Azure as well as on-prem, and they work the same way. The difference is how you would configure them, because, of course, being in Azure, you don't necessarily have the same infrastructure that you would have on-prem. So there is some uniqueness in how these are configured. So the first thing I want to talk about here is high availability in Azure when it comes to things like when your VMs are available. So there are essentially two different ways that you can ensure that within a high available SQL Server system like an availability group or a failover cluster, that the various VMs are going to be available. So one is an availability set and the other is availability zones. So with an availability set, you would put let's say it's a 2 VM system, you would put the 2 VMs, let's say it's an availability group, 2 VMs that are participating in your availability group would go into the same availability set. And that guarantees that they will be basically in the same data center, but they will not be down at the same time. So if one of them has to go down for patching, they won't both be down at the same time. So you put them in an availability set, and then we have different upgrade domains and fault domains. So this is a way for you to guarantee that at least one of those 2 VMs is up at any given time. With availability sets, you get 3.5 nines, 99.95% availability, but you get better performance because they are close to each other. With availability zones, you have the option of 4 nines, 99.99% availability. But with an availability zone, you would take those same 2 VMs and you'd put them in different availability zones, which is analogous to having them in different data centers. So you have slightly higher availability because they're completely separate, but they're not necessarily going to be close to each other, which means that your performance could suffer, particularly if you're doing a synchronous availability group where your transaction doesn't commit until it's committed on the secondary. So in those cases, you might have to trade off a little bit of performance, but you can get better resiliency. So it's up to you whether you want to optimize for performance or for resiliency. So availability sets versus availability zones. So once you've decided which high availability and disaster recovery technology that you would like to use, you have different options for how those are configured in Azure. So with availability groups, if you have the resource provider, if you've registered your VMs with the resource provider, then we give you some automated ways that you can configure availability groups. You can still configure them manually, kind of the same way as you would do with your on-prem systems. It's just that there's some uniqueness in how you would configure an availability group in Azure. For example, you need to have a load balancer for the listener in order to manage the traffic directing between the different IP addresses of the different systems. That's something that you wouldn't have to do on-prem. So there's some uniqueness with things like networking and load balancers and things like that, availability sets, etc., that you would need to manage in Azure that you wouldn't manage on-prem. So using things like Azure CLI or the Azure Quick Start templates allows you to a little bit quicker and easier setup of availability groups. We also have a new experience, which is currently in preview, where you can use the Azure portal to build an availability group. So again, it just kind of walks you through some of that configuration that's unique to Azure when you're setting up availability groups. You can also have failover clustered instances in Azure as well. When you do a failover clustered instance of SQL Server, you need some type of shared storage. The way this normally works for customers on-prem is you typically have a SAN that's connected to both nodes of the cluster, and then you let the cluster handle, reservations of that storage. So shared disk with using hardware. In Azure, obviously, you don't have that. So you have to think of something, you have to have some kind of shared storage, and there's a few different options for that. The first one is premium file share. So this is essentially a file share using SMB protocol to connect to. This is where you would put your SQL Server data files directly on the file share. So this is easy to set up and easy to manage, and it provides zonal redundancy, and all of this is managed by Azure for you. However, you generally will not get the same performance with your files on premium file share as you would if they were directly on premium SSD. There's no caching, which we talked about is really important for SQL Server workloads. And you have a lower IOPS and throughput for those file shares. So this is probably not the best solution for SQL Server workloads. It's it works, and if you have lower demands for IOPS and throughput, this may work for you. But for those higher IOPS and throughput requirements, you might want to choose something like Storage Spaces Direct, or S2D. So Storage Spaces Direct is a Windows technology that allows us to cluster the data disks themselves and then make those available to the clustered instance of SQL Server. So in this case, you can leverage those premium disks and those high IOPS and throughput directly by having them in a storage spaces pool. But there's a little bit more maintenance here because now you need to manage a Storage Spaces Direct cluster. So this may not be the best solution for everyone if you don't want to have that additional piece to manage. So the last thing I wanted to talk about for failover clustered, and something that is new that came out recently, is Azure Shared Disk. So with Azure Shared Disk, you can use either premium or ultra SSD, and then Azure Shared Disk works very much like your on-prem shared disk. So this enables a closer to a lift and shift scenario for your on-prem clusters. It works for all versions of Windows and all versions of SQL Server that are currently supported. And then this just leverages the failover cluster technology that you're used to using on-prem to manage the access to the shared disk. So this is going to give you the best compatibility with what you're currently running on-prem. And it's easy to use. So most of our customers are excited to try Azure Shared Disk for failover cluster because it gives you just the closest experience to what you have on-prem. So this failover cluster on Azure Shared Disk was recently released. So the availability right now, region availability is a little bit limited, but there's a step-by-step tutorial I've linked to here in the slide for how to configure an FCI with Azure Shared Disk, and there's links there that will tell you which regions this is currently available in, and it should be lighting up in additional regions throughout the rest of the year. So that's Failover Cluster on Azure Shared Disk. And another new feature that's coming out is distributed network names, or DNNs. This, using DNNs, allows you to bypass that requirement for having a load balancer. So this can help you just have a little bit less to manage using DNNs. This is a relatively new technology. However, this is available on SQL Server 2019, CU2, and later on Windows Server 2016. So again, there's a link here for how to configure the distributed network name for failover clustered instances. And I will let you investigate that. I'm not sure, again, since it's only available in SQL Server 2019, probably many of you are going to continue to need to leverage that Azure Load Balancer for your high availability solutions in Azure VM. But this is available for those of you that are on newer versions of SQL Server. And the last topic we're going to talk about today is backups in Azure. So if you're using managed instance or Azure SQL database, then of course we're managing backups for you, and all of your restores would happen through the portal. But when you're in an Azure VM, then backups fall to you to manage. So we essentially have three different ways that you can achieve backups in Azure VMs. One is automated backup. So if you're registered with the resource provider, then there is an automated backup solution. We also have Azure Backup for SQL Server. So this is a separate product in Azure that's available to you, which is a more enterprise class backup solution. And then, of course, you can just do your backups manually or use whatever process you're currently using on-prem, whether that be scripting, maybe you have like maintenance plans that include backups. Many third-party backup utilities also support SQL Server in Azure. Again, when you're running in an Azure VM, it's the same exact version of SQL. So whatever code is running on-prem can usually adjust easily to running in SQL in a VM. So whatever solutions you're using on-prem are probably still going to work in Azure. But we do have these additional options of automated backups and Azure Backup for SQL Server. So automated backups, again, this is available to you if the VM is registered through the resource provider. And automated backups are essentially just a wrapper on top of the managed backup to URL, which is something that's actually available in on-prem SQL Server if you're backing up to Azure Blob storage. And so what this does is really just create a series of jobs for you that run the backups. And it provides backup retention up to 30 days. It also supports backup encryption. So it's really just running your standard SQL Server backups, but it's just automating that for you and then giving you a portal experience for managing that. But the backups that are being created are just the same as regular backups. And again, also with point-in-time recovery as well. So your other option for backups in SQL Server is the Azure Backup Service. And so again, this is a fully managed service. It's an enterprise class backup solution. There is zero infrastructure for you to configure. They have everything set up for you. You simply enroll your VM and the databases that you want to have backed up. You enroll them with the Azure Backup Service, and then they take over everything for you. It provides long-term retention, up to 15-minute RPO. Whoops, I didn't mean to click that button. And point-in-time restores. And the nice thing about this is a central monitoring location for all of your backups. So if you've got, say, 100 VMs running in Azure, then Azure Backup for SQL Server VM provides you one location where you can manage all of those backups and a single dashboard for that, versus if you're doing either automated backups or your own manual backups, then you would be managing each VM individually. So this is great if you are managing a large number of VMs across Azure. The nice thing about this as well is you can take those backups, because they're just regular SQL Server backups. You can take those backups out of the Azure Backup Service and restore them as files. And then you can take that backup file and you can take it anywhere. You can bring it back on-prem. You can take it to a different VM. Like say, for example, you want to restore a database to a test system, either in Azure or on-prem, then you can get that backup up and put it onto a different system. The cool thing about that is something that's not actually available in managed instance or in Azure SQL Database, because those backups are not compatible with your on-prem version of SQL Server. But in Azure VM, it's the same version of SQL Server in the VM that you're running on-prem. So you can easily take those backups and move them between Azure and on-prem. So that's one of the cool features that you get when you're running SQL Server in Azure VM. So the Azure Backup Service for SQL Server VM, great enterprise class backup solution for all of your SQL Server VMs. And actually, Azure Backup has services for other VM types as well, not just for SQL Server. They just happen to have a plugin that works great for SQL Server. Okay, that's all I have for you today. Thank you very much for listening. Please do let me know if you have any questions. But I hope you can see after everything we talked about today that Azure VM is a great solution for running your SQL Server. And especially if you're taking that first step into the cloud, taking that on-prem SQL Server and moving it into Azure VM should be a straightforward and easy process for you. And the management experience that you get is hopefully just one step beyond what you're already getting on-prem. Thanks very much.